Good morning, AP Bio. Here we are with our trusty lab assistant right behind us. It's PCR and Gel Electrophoresis Day. In a minute, I'm just going to move the camera down more towards the lab bench so you can kind of see what's going on a little more. But let's set things up. We're going to do a little experiment here. And you have the student guide for this on the lambda-phage genome. We're going to amplify it from PCR. So let me show you some of the stuff we got here. Here is our PCR machine. This is what I told you. These things have changed dramatically. And what you're going to see when I open this up is it just has these little slots for these very small, I'll show you here, really small micropipette tubes. You can barely see that. I'll put it against my shirt as a little background. Very small, thin-walled micropipette tubes that we're going to do our stuff in. But you can see we can do a number of, we could do 4 if we were all in here doing these groups. 4 groups could be in here at once. And this thing is going to control the PCR time. And I've actually got my iPad here because you control it, as you're going to see, by their app, and you set the cycle times and how many cycles you want to go through to amplify your DNA. The other piece of equipment we have here after we get done with that is our gel electrophoresis, and our gel runs right in here. And so it looks a little different than things you see in your book, but the well sits in here, and you can see it's got a couple of electrodes on it that connect to the inside here where the positive and negative are. So we pop that into the machine. We're going to put our gel in there with some buffer, fill the wells with it. Now, when we get to some of this stuff, because I have to use the iPad to run this is why I'm trying to film with my computer, and because of COVID-19, I can't have somebody here with a camera that could directly look over the stuff that we're doing. Anyhow, couple things we have going. One of the things that we will be using today is the gel, and I just wanted to show you this for a minute. One of the things that has made this mini one stuff revolutionary is here's the gel, ready to go in little cubes that you can microwave in 20 seconds. Now here's the gel setup. You can make 2 gels. There's 2 wells here, and here's our comb that sits, so we can do 2 at a time. And you melt the gel, and I've already done it. I've got it pre-done for timing here. And then you pour it in here with the combs, and what the combs do is just leave holes there, because again, the whole idea of gel electrophoresis is you're running your, whenever you're sampling, in this case, the phage lambda stuff, anyhow, you're running it through and it will break down by size. And so you need the well so it gets in the gel and runs through the gel. And you'll see that as we go. So you pour them in there, and then after it would get poured, as I have here, I'll lift one up and show it to you. As it gets poured then, and you pull out the comb, and I want to be careful so it doesn't slide all over. But you can see that at the top, you have, or I'll put it at the bottom because you can see it, but you see those dimples down there. Those are actually holes in the gel. I'm just going to put it right in our gel electrophoresis setup. You've got the holes in there so you can put your stuff in it, and then it will be ready to run. Okay. So that's that. Let me move something out of the way here. Okay. So we've got those ready. And this is handy dandy. Making gels in the past with the agar powder and stuff, and maybe you did it a little bit if you had biology before AP Bio, and it was done for you. It's just smelly, it takes time, you gotta boil it, you gotta pour it. Like the plates that I made, the plates that we made, the little tiny plates we made, in the P-glow experiment, those are a type of agar also, and they just take forever. You know, that's a darker one. These are clear. But anyhow, just wanted to point that out to you. Okay. All right. So here's our procedure. We're going to get ready to go with this. I'm going to open it up in a minute. And then what we're doing with the procedure, and I'm going to dip this down so you're not staring at my face, but looking at stuff here. What we have to do is I've labeled each of these micropipettes, and I'm using our little floaties from the PCR lab. I've labeled them P1, P2, P3, and the negative control. And if you look at your experimental procedure, just like mine, there's a few things that we have to add. So I'm going to pop the tops off. And then we're just going to use a micropipette to pop it in. And this, unfortunately, is one of the reasons it's unfortunate that you are not in the lab doing this right now, because this is one of those skills that you put on your resume, is that you've used a micropipette before. Okay. Now, if you look, they're all getting 10 microliters, and I've got it set at 10 microliters of the fast hack master mix, blah, 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 blah. That's the specialized enzyme that, that's the TAC polymerase that works. So I've just got them open. Now the thing is, the tubes are empty. So I can use the same tip with every tube through most of this, because it's not going to change or contaminate anything. These work very simply. You push down, and the first stop is for drawing stuff up, and that's going to be 10 microliters. I can see in the tip. And then I put it in, and I want to get it towards the bottom. And then I push it all the way until it goes to the bottom. So past that first restriction point, and then I just put it in the tube and get all the stuff set in the tube. Okay. And again, you don't let up on it until you have gotten things out of the, till you pulled your micropipette out of the tube. Okay. And so that, you can't see it, but it's a little 10 microliter drop on the bottom. Okay. Very nice. Now, the second thing that you see everybody gets is 5 milliliters of the lambda DNA phase. So I'm just going to dial this down to 5 microliters. Okay. This pipette ranges from 2 to 200. So it does pretty good. So then I've got to grab my lambda DNA. Here it is in the orange cap. And again, since they're all getting the same thing, including the control, I can actually use the same micropipette tube for all of them. And so again, I'm just going to shoot that 5 microliters into all of them. Okay, get rid of that tip. And now is when everything changes. Now I have to use a separate tip for all of them. Okay, and you can see that in number 1 is going to go primer set number 1. Okay. So in we go. We get our 5 microliters in. That one goes. Done. Now I need a new tip. Number 2 is going to get primer set number 2. Make sure I put it in number 2. There we go. Number 3 goes in primer set number 3. And then the control, the negative control, just gets some sterile water that they send along with sterile dehydrated water. Might help to get a tip on it. Okay. All right, I'm going to set the stuff aside for now. And then the next step, I'm just going to close them all up. And then I'm going to give them a little tap. I don't have a microcentrifuge this small, but I'm going to give them a little tap to make sure everything is at the bottom. Being careful, these are very thin-walled extravaganzas, so I don't want to crack them. I am trying to tap out any little bubbles in there also. Sometimes you can give them a flick. That took care of that bubble. Same thing here. Let's flick out that bubble. Tap it all down. And then they're all set to go in the thermal cycler. So let me help you with the camera here. Here we go. So moving this out of the way, I'm just going to load them up. And you can see they just go and sit right in here. Okay. And my control. Okay, got them sitting in there. Okay. All right. And then here's what you got. I'm going to shut her down. Oops. I'm going to turn it on. I'm going to shut it off. And then here, I'll try and show you I'll get you the app here. Okay. Now I'm going to open my mini one. And this was a previous protocol that I had run. Anyhow, I'm going to cancel this. Okay. One device found. If you can see, it's kind of hard to see, but one device found. Okay. And that's I want to connect. This is all Bluetooth connected. And I'm going to set new protocol. Okay. And I want to go to PCR. So I'm going to hit PCR and then go next. And I want to start with the initial denaturation. And then what you can see is it gives me this graph. It's kind of hard to see with the lighting, but it gives me this graph and I can type in the temperatures in the protocol. So in the initial denaturation, we want to have this thing according to our table at 94 degrees, and we're going to go for 5 seconds. And actually on this, it goes from stage 1 and also a little bit into stage 2. So I put it in both. I'm typing 20 into the cycles I want because that's what it tells me. Then it cools down to the annealing stage when the primers and stuff will do their action. And that's going to happen at 54 degrees. Okay? And again, it just has it for 5 seconds. Okay? And then we're going to get to the extension phase. I got to move up here. And that's what's going to happen. That's where the Taq polymerase comes in. That's at 72 degrees and 5, and that's when you start really copying the stuff. Okay. And then I'm done with that. So I've got it all typed in. I'm kind of showing it to you sideways. And then all I'm going to do is hit run. And it's going to run for, 16, 17. Oh, I forgot to name it. Hold on. I'm going to name it lambda. Lambda, if I could spell Lambda 101. Okay. And then I'm just going to hit run. And it's going to give me this screen here that tells me all my protocols and stuff. And then I have a big green start. And now you can hear it and see it. And this is going to show me that it's going through, you know, where's it at in the stage 1, stage 2, stage 3, and how many cycles. It's estimating 16 minutes and 46 seconds. And I can also watch it here. Okay. So anyhow, that's where we're at. I'm not going to have you sit there for 16 minutes. So I'm going to pause recording, and then we'll come back when she's done and throw her in the gel. See you in a bit. Okay, we're back. Our thermal cycler has finished. It did its thing. And, you know, the nice thing about this is you can leave it overnight. When it stops, it just keeps everything at 4 degrees Celsius where it should. Anyhow, I'm going to remove all our stuff. And then all we have to do now is add in some loading dye. And then we can plug it right into the gel and run the gel. Okay. So that's what I've done. Keep an eye on where I've got everything. All right, so I'm going to turn off the thermal cycler and put it down. And now we're going to come over and focus more here on our gel electrophoresis. But first, I've got to put some stuff into each of our things. And if you look at your protocol now, before we do the gel electrophoresis, now I need to put loading dye into each one of them. Not that one. This is what I want. It's a loading dye. It's a dye so you can see it. I'm going to pop them each open here. It's a dye so you can see it as it runs through the gel, and we put the light through it. And unfortunately, again, because you have to use your iPad, I suppose I could have used my phone. You can run it off your phone also. I could have Bluetooth with my phone. Maybe next time I'll do that. That I can't quite take pictures, but I'll take pictures and put them in another video or something for you to see. Load them up on a PowerPoint so you can see as we talk about finishing up in a different video. Anyhow, so 5 microliters of each. Get the loading dye. Okay. So I'm just going to go through and do the same thing we did before. And again, I can use the same tip here for all of them, as long as I don't get it down into the solution. So I'm just putting it really on the side of the micropipette. And I'll show you as soon as I cover it up and set this aside. So I'll show you one here where it has a rundown. You can barely see that little dot. I just put it on the side. I'm going to cover it. And again, I'm going to tap it so that it just goes down and mixes with, and give it a little flex so that it mixes with our stuff. Okay. Do that with all of them. Little tap, little flick. Okay. Little tap, get it in there. Okay. So that's all set. Now, I'm going to take the cover off. You can see I've got the gel in there. I have to be careful with it. I've got the gel in there. I've got it all oriented. Okay. Now, here's the buffer. It goes into a buffer. So into one side of the gel, I'm just going to pour, and for this, it's exactly 135 milliliters. But you just pour into one side of the chamber, and you let it take itself across to the other side of the chamber. Okay. And fill up, and there we go. So that's done. So that's ready to go. Okay. And now I'm going to load all the wells. And again, this would be beautiful if you were standing over my shoulder. This takes a steady hand and a happy heart. Let me open all these up, get them ready to go so I can just grab them and go. And I'm just going to put them in order in the wells, and I'm going to follow the order that it tells you on your thing. We have a marker DNA, okay, for the phage lambda here, and it's already got its gel in it. But we've got the marker DNA right here that we're going to put in well 1, and that's what we can compare against. Now we're going to put 10 microliters of each, so I have to dial this back up. And again, I'll be using a separate micropipette tip with each. Okay. And this is the tricky part, and this takes skill loading gels. Okay. So, for example, I'll grab the marker DNA. It's already got the loading dye in it. I've got 10 microliters. And here's where you take the steady hand, because you need to get into well 1. You don't want to go through well 1. You just want to make sure you're in well 1. Insert everything in, and then done. So you get a nice little line. And I'll show you when they're all done. But you get it in the gel. You don't poke it through the gel. And get it setting in that little well you made with the comb. Okay. Now I'm going to put P1 into the next well. Steady hand, I just make sure the tip's in there. And out we go. Okay. And that is not the one I want. I want number 2. There's my number 2. And here goes number 2, P2. That's my control. This is number 3. I'll tell you one of the issues with these really thin wall micropipettes that you use in this thing is they're really too small to write on. Get this in well number 4. Last but not least, our negative control. Will go in the last well. Now I can't move the gel. We'll see if I can do this with my computer and get you a visual. And I can't really see, but hopefully you can see in there that I have the wells. You can see a little green filling in the 4 wells. The one on the end, the one on to my right, but probably your left, is empty because it gave me 6 wells. Anyhow, so that's it. It's full. I put this on here to cover it, and then I just turn it on, and I'm going to let it go. And again, I'm going to let it go for about 20 minutes. It's got a couple of lights on it so I can watch as the gel goes and a screen. But I'm going to let it go for about 20 minutes and watch the band separation as it goes. I'll take some pictures along the way and then try and show you those pictures in the analysis. But anyhow, I'm going to pause the recording for a while now. See ya. Okay, we're back, and I'll show you what's going on here, and you can kind of see the light go on and off. We are running, and we were running fine. I've taken a couple of pictures with the help of my lab assistant here, and it's fine. It's very interesting though that the marker isn't running, the left side marker. And I've got a couple pictures because this wasn't, I did this a couple times today. One where I did it without you, just ran it through, and then the one where we filmed. And on each of them, there wasn't great perfection. I mean, it was okay. This one has our P1, P2, and P3 running as bands as they should, but somehow the marker didn't come through, and that's not anything I touched. On the first one, the marker and 1 and 3 came through, but 2 didn't come through, which wouldn't be as surprising because sometimes the mix or things go on, or it didn't set in a gel real correctly or anything else. But I'll show you the pictures of both, and you'll get an idea. Either way, what you do is you get to see some nice professional banding. And between the two pictures, since they're essentially the same thing, since they really are the same thing, you'll be able to kind of see the marker and see how the different lambda phage bands kind of come out depending on whether we use primer 1, 2, or 3 in the primer set, so where they took up and what they were copying. Anyhow, we'll see that as I do the results video and kind of put some pictures on. But that's it. We PCR, we gelled, we came together. It was a beautiful thing. And we will talk to you later. Have a great day.